Assalamualaikum warahmatullahi wabarakatuh. We are from group B7. We will present it about communication statistic. First, I will introduce myself. My name is Hasangga Gunggunawan.
Chapter 7 Casual Research Design Experimentation. In this chapter, we will talk about concept of causality, condition for causality, definition and concept, definition of symbol, validity in experimentation, and many more. First one, we will talk about concept of causality. Scientific concept of causality is complex. Causality means something very different to the average person on the street than to a scientist. A statement such as X cause Y will have different meanings to an ordinary person and to a scientist. This example you can see in this presentation. The second, we will talk about condition for causality. In this part, we will talk about concomitant variation, time order of occurrence of variables, absence of other possible causal factor. Concomitant variation is the extent to which a cause X and the effect Y occur together or vary together in the way predicted by hypothesis under consideration. Evidence pertaining to concomitant variation can be obtained in the qualitative and quantitative manner. Then the time order of occurrence of variable by definition is an effect cannot be produced by an event that occur after the effect can has been taken. The third is the absence of other possible causal factor means that the factor or variable being investigated should be the only possible causal explanation. The third is definition and concept. Definition and concept is divided into the 6 elements. First one is independent variable. Independent variable are variable or alternative that are manipulated and whose effects are measured and compared. Second is the test unit are individual, organization, or other entities which respond to the independent variables or treatment is being examined. The third is dependent variables. Dependent variables are the variables that measure the effect of the independent variable on the test unit. The fourth is external variable. External variables are all variables other than the independent variables that affect the response of the test unit. The experiment is formed when the research manipulated on or more independent variable and measure their effect on one or more dependent variables. While controlling for the effect or external variable, and the rest is experimental design. Then we will talk about definition of symbol to facilitate our discussion of external variable. The specific experimental design, we define a set of symbols that are commonly used in the marketing research. You can see the example in this presentation. Next is validity in experimentation. In this part, we will talk about internal validity and external validity. Internal validity refers to whether the manipulation of independent variables or treatment actually cause the observed effect on the dependent variables. The internal validity refers to whether and the cause and effect relationship found in the experiment can be generalized. In this section, we classify external variables in the following categories. history, maturation, testing, instrumentation, statistical regression, selection bias, and mortality. The various categories of external variables are not mutually exclusive. 10. Controlling external variable. External variable represent alternative explanation of experimental results. They pose a serious threat to the internal and external validity of an experiment unless they are controlled for. They affect the dependent variable and thus confound the result. For this reason, there are also carrot confounding variables. There are four ways to controlling external variables. The first one is randomization, matching, statistical control, and design control.
Experiment and event. Experiment related to things planned to be done, the result and the experiment are called event. Formulation opportunity. First, classic formulation to objective approach or relative frequency, and the last subjective approach. Classification of experimental design. Classification of experimental design can be classified as pre-experiment, through experiment, pseudo-experiment, or statistic. Pre-experimental design do not employ randomizations to procedures to control for extraneous factor. Example for this design include the one-shot case study, the one-group pre-potas design, and the statistic group. One-shot case study where one group of unit test is exposed to treatment X and then a single measurement on the dependent variable is taken. One group pre-potas design, a pre-experimental design in which a group of unit test is measured twice. And statistic group design is experimental design of two groups called the experimental group of EG was exposed to treatment and the other called the control group is GG. Measurements in both groups were carried out only after treatment and the test unit was examined randomly. In true experimental design, researcher can randomly assign the test unit and treatment to experimental group. Include this category: the pre-potas control group design, the potas only control group design, and the Solomon group design. Potas group design is the experimental group was exposed to treatment, but the control group was not. Pre-test and post-test action were carried out in both groups. Control design only post-test, where the experimental group was exposed to treatment, but the control group no pre-test was taken. And the last Solomon for group design is the true experimental design that explicitly control the effect of interactive testing in addition to control other foreign variables. Quasi-experimental design result will when the researcher is unable to achieve the full manipulation of schedule or allocation of the treatment to test the unit, but can still apply part of the apparatus of the true experimentation to such design as time series and multiple time series design. Time series design involved the series design or time to series design was a variable for a group of unit tests. This treatment is given by the researcher or occurs naturally and periodic measurements. Multi-time series design is the design a time series that includes another group of test unit to function a control group. And the last statistical design is the series of basic experiment that allows for statistical control. And Analysis of external variables. The basic design used in statistical design include the pre-experimental, true experimental, and quasi-experimental. Statistical design are the classified of the basis of their characteristic and use. The important of the statistical design include the random Z block, Latin square, and factorial. Laboratory versus field experiment. Uh, Experiment can be carried out in laboratory or field environment. The laboratory environment is artificial, which was built by researchers with the condition desired specifically for the experiment. Then the term field of environment is identical to actual market condition. Laboratory experiments have a several events over the field experiment. Environmental laboratories offer a high level of control because they isolate the experimental is carefully monitoring of the environments. Therefore, the historical effect can be minimized.
Experimental versus non-experimental. These are three types of research design: exploratory, descriptive, and causal. Of these, only the design of causality is really appropriate for deducing causal relationship. Although descriptive survey data are often used to provide evidence of causal relationship, these studies do not fulfill all the requirements needed for a causal relationship. Next, limitation of experimentation. Time experiment can be time-consuming, especially if researchers are interested in measuring the long-term effect of treatment. Costs experiments are often expensive. The recruitment of the experimental group, the control group, and several measurements significantly add to research costs. Administration. Experiment can be difficult. It might not be possible to control the effect of foreign variables, especially in the field environment. Application test marketing. Test marketing and application of control experiment done in limited but carefully selected test market involves a replication of the planned national marketing program for a product in test market. Test market, a carefully selected part of marketplace that particularly suitable for the marketing. Standard test market, a test market in which the product is sold through regular distribution channels. For example, a sample consideration are given to product sampling because they are being test marketed. Next, control test market, a test marketing program conducted by an outside research company in fact experimental. The research company granted the distribution of product in retail outlet that represent a predetermined fragment of the market. Simulated test market, equate market which respond are presolid, then interview and observe the process and attitude toward the product. Electronic, virtual, and web-enabled test market. An electronic test market combines consumer scanner, panel, store distribution, and household level media delivery in the site market. Next, international marketing research. In many countries, marketing, economic, consumer information, and technological information have to be developed software in the United States. Even when experiments are designed, it is difficult to control the timeline of the occurrence of variables and absence of possible causal factors. Two conditions need to form causal relationship because research have a far less control over the environment. Foreign control of variable is very problematic. Ethics in marketing research. It is often necessary to discuss the parts of an experiment to produce valid results. This product is called debris. This can the true purpose of study, the nature and the must be fully explained to respondent and must be give the opportunity to withdraw the information. This procedure is called debriefing. Disclosure in the way cannot be best result.
Assalamualaikum warahmatullahi wabarakatuh. My name is Putri Dwi Risni Ananda, and today I want to explain our presentation about Chapter 8, Measurement and Scaling Fundamentals and Comparative Scaling, Malhotra book. Okay, measurement means assigning numbers or other symbol to the characteristic of the object in accordance with predetermined rules. And scale is a making of a series of units where the measured objects are located. Scaling can be considered as an extension of the measurement. Okay, next is scale characteristic and levels of measurement. First is description. Description is a unique label or descriptor used to determine each scale value. All scales have a description. The second is order, relative size or position of the descriptor. The sequence is represented by descriptor as greater than, less than, and equal to. Third is distance. Distance characteristic means that the absolute difference between scale descriptors is known and can be expressed in units. And the last is origin. The origin characteristic means that the scale has a unique or fixed star or correct 0 point. Primary scale of measurement. Nominal scale, a scale where numbers or symbols only function as labels or text to identify and classify objects. Ordinal scale, the rating scale at which numbers are assigned to objects to indicate the extent to which some characteristics are possessed. Interval scale, the scale at which numbers are used to judge objects. The scale ratio, this allows to research to identify and classify objects arranged to the order of objects. Comparison of scaling technique. Comparative scaling technique involves direct comparison of stimulus objects. Comparative scale data must be interpreted in relative terms and only have ordinal or ranking order properties. For this reason, comparative scaling is also referred to as non-metric scaling. The second is non-comparative scaling technique. On a non-comparative scale, also referred to as a metric scale, each object is scaled independently of the other in the stimulus set. The resulting output is generally assumed to be the interval or ratio to be scaled. Ethics in marketing research. Researchers have a responsibility to use the appropriate type of scale to obtain the data needed to answer research questions and test hypotheses. It's a responsibility of research to obtain the most accurate data. SPSS window. Research can design one of the main types of scale, nominal, ordinal, interval, or ratio. We can design a scale in addition, pairwise, comparison, ranking order, and constant amount scale can be easily implemented. This software can be purchased separately from SPSS.
Chapter 3 Opportunity, Der Gibson.
Basic event and sample rule. In calculating the probability of an event, it is necessary to identify in detail the relevant events of an experiment. The simple event that is the result of an experiment is called a basic event. A collection of the all basic events is called the sample space. while the number of basic events that might be called the size of the sample space. Calculation of sample room size in the size of the sample space and considered is small. The calculation is not difficult as the size of the sample space increases or the complexity increases. Calculation become more difficult. There are several ways to calculate the size of the sample space, namely multiplication, permutation, and combination. Then opportunities for various events. This section is divided into three. The first one is mutually exclusive event, independent event, and independent not free. Random variables and expectation value. Random variables are variables in the form of real numbers whose variation in the value is determined by a random experiment. For example, in the two toes of a coin, if x the number of faces that appear, then x is called a random variable because the value can vary according to the result of the toes. In the case x, fill in the set 0, 1, and 2.
Expectation value is the measure of centering weighted average of the random variables that have been previously defined. Because the variable is random, consisting of discrete and continuous, the expected value can also be discrete or continuous. Suppose x is random variable and p is a chance of occurrence of random variable x. Opportunity distribution. In general, the opportunity distribution is divided into the opportunity distribution and continuous opportunity distribution. The discrete opportunity distribution is the distribution of opportunities for discrete random variables, while the continuous opportunity distribution is the distribution of the opportunities for continuous random variable in this book. The discrete opportunity distribution will review the binomial opportunity distribution and the Poisson opportunity distribution, while for the continuous opportunity distribution, the normal opportunity distribution, T distribution, Chi squared distribution, and E distribution.
Gosset found that using the sample standard deviation to estimate the size of the population standard deviation or 0 in calculating the value of z for a standard normal distribution table does not apply to a small sample. So when faced with such condition, another table is needed. C-squared distribution. C-squared distribution is distribution for continuous variable whose magnitude is equal to the sum of square of a number of value of z for x with spread normal. C-squared values start from 0 to infinity, so it will somewhat different from the T distribution. The shape of the curve varies depending on the degree of freedom.
SPSS window. Research can design one of the main types of scale, nominal, ordinal, interval, or ratio. We can design a scale in addition, pairwise, comparison, ranking order, and constant amount scale can be easily implemented. This software can be purchased separately from SPSS.
Number 1. Use a calendar that systematically takes samples every 18 days starting on January 6th. Answer using systematic sampling with an 18 days interval starting from the 6th. It can be sampled on January 23rd, February 10th, February 28th, March 7th, April 4th. Next, number 4. A population is divided into groups. Each group has a large variation, but between groups holds a small variation. When you will draw samples from the population, which technique do you use? Answer: using the sampling technique cluster, because each group has a large variation but between group has a small variation. We use a sampling of strata when each group has a small variation but its intergroup variation is large. In contrast, we use cluster sampling when there is a variation in each group but relative intergroup is equal.
The question number 3. Perry Sandria, public relations manager at a company, want to know the effectiveness of advertisements that have been made lately. For that, she took a telephone book to contact customer randomly. What sampling technique should she do? The answer is using a simple event sampling technique, because every element of the population has the same opportunity to be selected as a sample.
So I will answer question number 4. Production manager at the manufacturing company must be assured that they are not defective products so that they are worth selling. So far, the biggest factor that makes a product defective is engine damage. To find out when the machine is repaired or not indicated by the number of defective product because it is not possible to inspect every product. Sampling is done. Which the technique is better? And the answer is using judgment sampling technique because the sample is taken based on criteria that have been formulated in advance by the researchers, namely the criteria based on which machine is defective.
Make an example problem about the sample. Thus the technique used is the sampling cluster. The answer is research wants to know the average salary of doctor in Indonesia because it's very important and very different than the following. The first step is to determine the doctor's page sample for the example 12 random sample. The second stage, name taking samples at age invited by the special group.
Univariate tutorial. First, open SPSS software version 26. After that, click variable view. Then, in the name column and label column, fill in with the variable name. In the value column, fill in with the interpretation of the variable name code. 1 for 17, 2 for 18, 3 for 19, and 1 for yes, 2 for no. Data that has been coded into data view. Next step, click Analyze, then click Descriptive Statistic and select Frequency. Move the existing variable, then click OK. The following is the output. In the same data, we will analyze the bivariate data. Click Analyze, then click Descriptive Statistic, then transfer the age variable to row and the user variables to column. In the cell section, check column and total, then after that, click OK, then the bivariate data analysis result will appear.
Validity testing. In this study, we use as many items as 5 questions, with respondents as many as 10 people. Validity test steps. First, open SPSS software, then click Variable View. In SPSS table, we fill with question item according to the number of questions in the questionnaire study. Item 1, item 2, item 3, item 4, item 5, and next, in the decimal part, we change all to 0. Next. After that, move the data view. We copy paste all the data questionnaire result. Then, to test all the false items, we click on Analyze. Next, select Correlate and click Bivariate. Then, Ctrl A, all items, and input into the variable column. Click OK. After that, will output the result like this. After getting the data, then compare the total score of each item with table result. The table of this result is 0.374. If the T count is greater than the T table, then the result is valid. However, if T count smaller than T table, then the result invalid. Reliability testing. In this result, we use as many items as 5 questions, with respondents as many 10 people. Reliability test steps. First, open SPSS software, then click Variable View. In SPSS table, fill with question item according to the number of questions in the questionnaire study. Item 1, item 2, item 3, item 4, item 5, and next, in the decimal part, we change all to 0. Next. After that, move to the data view. we copy paste all data questionnaire result. Then, to test all those items, we click on Analyze. Next, select Scale and click Traceability. Analyze. After that, control all items. Accept the total score and move into the item column. Then click Statistic and click Check Scale if item deleted. Click Continue. After that, click OK. Then it will accept the view as follows. And the form data describe the traceability is reliability because the cron batch alpha number is known. Then the minimal cron batch alpha value of 0.6